Today we will talk about the angular displacement and its SI unit and how it is converted into other things. Let us see angular displacement, its SI unit radian. Let us see what is the angular displacement and what's the radian. First of all, I will define angular displacement. I will say when a body moves in a circle, suppose this is a circle and what body is moving, and this is the initial line OA. Body is moving in circle, suppose at particular time it reaches at B, this point B. Now this angle, this is the angle traveled in the circle, this angle theta. Suppose any angle theta. Now this theta is known as the angular displacement. Actually, the angle subtended or angle made at the center of the circle when a body moves in a circle. So I will say when a body moves in a circle, then angle made or subtended by the body at center of the circle with respect to initial line. Initial line is known as angular displacement. Actually, its nature is a vector, but in our course, vector or scalars, for this angular displacement not mentioned, we have not to mention it. Actually, it's a vector, but we will not be mentioning whether it's a vector or a scalar. We will be just treating it as a physical quantity, although it's a vector, but we will not be taking its vector nature. So let us see, suppose when a body moves in a vertical circle, and when it goes from A to B, now at a particular point body is at B, then this angle made at the center of the circle is known as angular displacement. It's a vector quantity. It is usually represented by theta or angle. Now what is the SI unit of this? Actually, SI unit of the radian, SI unit of angular displacement is radian. SI unit of angular displacement, SI unit of angular displacement is radian. SI unit of angular displacement is radian. Now radian is neither a base quantity, base unit, neither a derived unit. It's just a second unit. Actually, radian is just it is dimensionless. It's just a number to represent an angle. So radian, how we define 1 radian? The question is how we define 1 radian. See, definition of 1 radian. That's very important. Usually examiners ask this definition of 1 radian. I will say first definition. I will show this suppose diagram. I will say theta is equal to 1 radian, or I can say our angle AOB is 1 radian if arc length AB is equal to radius of the circle. It means, suppose if this radius is 3 centimeters and this arc length, if you have a thread and put the thread, affix the thread here always, and then where its length, and this is also 3 centimeters, then this angle is 1 radian. So whatever, suppose 4 centimeters, this is 4 centimeter arc length, then the angle subtended to the center is always 1 radian. This is one definition. I can define it another way also. There's the same definition, but we can even the more inverse form. I will say angle subtended at the center of the circle will be 1 radian if arc length, subtended arc length, which is making the angle is equal to radius of the circle. Or I can say if AOB, it is AOB angle is 1 radian, if arc length AB is equal to OA or OB radius. That's the definition of 1 radian. Now 1 radian roughly is equal to 57.3 degree roughly. Or you can think about a 60 degree angle, just roughly. Think about just a 60 degree angle, you can call it 1 radian. Its exact value is not exact, this is also approximation 57.3 degree. But how can we change radian into degrees and degrees into radian? Actually, in entire circle, we say there are 2 pi radians in a circle. 2 pi radians in a circle. When there are 2 pi radians in a circle, actually there are also 360 degrees. So I can always say that 2 pi radians is equal to 360 degree. Or I can say pi radian is 180 degree, where pi is approximately 3.142 in physics. Although this is an approximation value, otherwise this is a rational number. It cannot be expressed in decimal. It cannot be expressed in fraction form accurately. So, but please, I tell you one thing, you shouldn't think a pi is 180 degree. Pi is not 180 degree. It's a pi radians are 3.142 radians is 180 degree. How can we take, suppose 1 radian will be then equal to 180 degree upon pi. Pi is 180 degree upon 3.142, and if you divide, almost it comes to 57.3 degree. So 1 radian is 57.3 degree. Now how we can change radians into degrees and degrees into radians? Actually, the ratio method is very easy to change. For example, I can change suppose 90 degree. How I can change 90 degree radians? If you change 90 degree radians, you can have, first is this formula, not the formula, the ratio method. I will say 2 pi radians is 360 degree. So 90 degree will be x radians. So x will be equal to 2 pi into 90 upon 360. This is pi over 2 radians. And if pi's value is given 3.142 divided by 2, whatever value comes, that is the radians. You can change radians into degrees into radians. But there is always a formula. Formula is, if x is given in degrees, just multiply it by pi upon 180, it becomes in the radians. Here the example. Suppose if I have 90 degree, it will be 90 into pi upon 180, 0 gone. So it's pi upon 2 radians, or it is 3.142 divided by 2. So whatever it comes, I do not have a calculator today. So whatever comes, it will be in radians. So similarly, for example, if I say change this, suppose pi over 4, suppose what is the 45 degree? How much 45 degree in radians? I can change it, suppose either by this way, either by this one. So I will say 2 pi radians is equal to 360 degree. 2 pi radians 360 degree, and how much 45 degree will be equal to, we can change in that way. Similar is the case, we can change also radians into degrees. For example, if I have pi upon 4 radians, how much degrees is that? Actually, in physics, values are not given in pi, values are given in decimal fractions. So I can say pi is 3.142 divided by 4. It is almost, I think, 0.785 or 0.786. It is 3.142 divided by 4. It is almost 0.786 or 785, almost. So this pi over 4 radians, 0.786 radians is how much degrees it is equal. So I will take ratio method. Ratio method is, I will say 360 degrees are 2 pi radians. So pi upon 4 radians on x degrees. So I'll be calculating x will be 360 into pi upon 4 divided by 2 pi. So this pi is cancelled and this is 90 upon 2, so it's 45 degree. Or it's simple in that I can write in this way. The other formula is if something is given in radians, x is in suppose radians, then just multiply it 180 upon pi, it becomes in degrees. So here it's pi upon 4, so it is just, I will write pi upon 4 into 180 upon pi, pi is cancelled and it's 45 degree. That is, now why students think the pi is 180 degree? Sometimes they have an easy cut over there. They say pi upon 4, just write 180 degree upon 4, so it's 45 degree. That is why sometimes they think the pi is 180 degree. But actually they are replacing pi radians by 180 degree, which is right. So pi radians is 180 degree. It is not the pi which is 180 degree. So we can change this by this way. For example, if you have a cycle, suppose 2 cycles. How many radians are in 2 cycles? One cycle is radian 2 pi. One cycle or one rotation is radian 2 pi. So there are 2 cycles, it will be 4 pi radians, and I can have angles also. So we can change in this way radians into degrees and degrees into radians.